Hello! Today, we're diving into an exciting video where we'll explore the effects of the mesmerizing Perseid meteor shower on the International Space Station and the satellites orbiting our planet. This incredible natural phenomenon, which peaks every August, captivates millions of stargazers worldwide, yet there's a far more complex scenario unfolding in space. So, what are the potential dangers lurking behind this captivating display, and how are these risks managed? We'll dig into these questions and uncover NASA's insights, their strategic approach, based on scientific data, and how they protect our space infrastructure. If you're ready, let's embark on a journey into the depths of this unique and fascinating topic. Meteor showers are spectacular celestial events that occur when cosmic dust particles left by comets traveling through space enter Earth's atmosphere and burn up, creating bright trails known as shooting stars. Various meteor showers can be observed throughout the year, but the Perseid meteor shower stands out as one of the most popular and impressive. The Perseids can be seen from late July to mid-August each year, during which 60 to 100 meteors per hour may be visible, offering a breathtaking visual spectacle for sky enthusiasts. This intense meteor activity captures the attention of both amateur and professional astronomers. The source of the Perseid meteor shower is the comet 109P Swift-Tuttle. As this comet travels in its orbit around the Sun, it leaves a trail of fine dust and rock fragments. Each year, as Earth passes through this trail, these particles enter our atmosphere, ignite due to friction, and produce the meteor shower seen in the sky. What makes the Perseids particularly remarkable is the bright and long-lasting trails they create in the night sky. These meteors are usually quite fast and can leave long streaks of light as they burn up in the atmosphere. The trails left in the sky provide viewers with a brief yet unforgettable experience. The best time to view a meteor shower is in the hours after midnight. During these hours, the number of meteors entering the atmosphere increases due to Earth's movement. In areas with open, dark skies and minimal light pollution, the Perseid meteor shower can be observed in all its glory. Observers should opt to watch with the naked eye, since using telescopes or binoculars might restrict their field of view. The Perseid meteor shower holds not only scientific significance, but also cultural and historical importance. Throughout history, many cultures have interpreted this celestial event in various ways and incorporated it into their mythologies. This magnificent display in the night sky continues to inspire not only scientific research, but also the worlds of art and literature. In conclusion, the Perseid meteor shower is one of the year's most thrilling events for sky enthusiasts. This natural phenomenon, which holds both scientific and aesthetic value, invites people of all ages to gaze up at the sky and witness the universe's enchanting beauty. This year, the Perseid meteor shower is expected to peak on August 11-12. But does this captivating meteor shower pose a threat to astronauts on the International Space Station and satellites? Bill Cooke, the head of NASA's Meteoroid Environment Office at the Marshall Space Flight Center in Alabama, provides a clear explanation regarding the meteoroid threat in space. In most cases, absolutely not. Especially if you're inside the International Space Station, meteoroids pose zero risk. Astronauts on the space station are protected from meteoroid impacts by an advanced protective shield known as the Whipple bumper. This shield breaks up meteoroids instead of deflecting them, distributing their energy throughout the shield to keep the station safe. The Whipple bumper is named after its inventor, Fred Whipple, who developed the dirty snowball model describing the structure of comets. This shield consists of metal plates, including Kevlar. Cooke emphasizes the station's resilience by saying, "The odds of a meteor entering the space station are very low." You can think of the space station as the tank of low Earth orbit. When astronauts venture outside the space station, they might notice small bumps and dents on its surface. However, only about half of these depressions are caused by meteoroid impacts. At the ISS's altitude of 230 to 285 miles, half of the impacts are caused by space debris, and the ISS occasionally has to maneuver to avoid this debris. meteor showers pose almost no problems for the ISS. As Cooke points out, 90% to 95% of the danger comes from the sporadic background of meteoroids, which are cosmic dust particles that are always present and not associated with any shower. This is a significant threat, especially for astronauts on spacewalks. Before any spacewalk, Cooke's office issues a meteoroid forecast to ensure that the risk of an accident has not increased. These forecasts play a vital role in planning spacewalks. The Geminids, the most intense annual meteor shower, which peaks in December, account for only about 60% of the sporadic background risk. Cooke notes, meteor rates only rise significantly during a meteor storm or outburst. Meteor storms or outbursts are intense meteor showers where potentially more than 1,000 meteors can be seen per hour. These storms occur when Earth passes through dense trails of dust left by comets. Meteor showers like the Leonids and Draconids can provide spectacular visual displays during such storms. Some meteor showers have become unforgettable events in history. For example, the Leonid meteor storm has had several consecutive storm years every 33 years. The last Leonid storms occurred between 1998 and 2001, and the next storms are expected in the early 2030s. These events happen when Earth encounters dense dust clusters from the Tempel-Tuttle comet. Draconid meteor showers can have less predictable storms. A Draconid storm in 1933 produced 6,000 meteors per hour, but the most recent storm in 2018 only produced 150 meteors. The Perseid Meteor shower can also experience intense bursts from time to time, with the most recent one occurring in 2021. During meteor storms and outbursts, the ISS and other satellites take various precautions. Spacewalks are postponed, and spacecraft position themselves to protect against impacts. For instance, the Hubble Space Telescope reorients itself to avoid facing the radiant point of the meteor shower. Cooke compares this to adopting a nuclear strike position with your backside to the radiant. The risk for any satellite is minimal because each one has a small cross-section, only a few tens of square meters. In comparison, the ISS's solar panels alone cover 114,000 square feet, and even this pales compared to the vastness of the night sky. Cooke explains, when I'm lying on my back, looking at the night sky, I'm taking in about 30,000 square kilometers of atmosphere where the meteors burn up. Now compare that to a few tens of square meters, so the odds of a meteor hitting a satellite are low. However, the risk is not zero. In rare cases, satellites have been hit, but the only satellite permanently destroyed by a meteor shower was the Olympus communications satellite during a Perseid outburst in 1993. A few satellites have recorded anomalies due to small impacts, and one or two have been knocked off course by meteoroid hits. Cooke notes, for example, a few years ago, a NOAA satellite got hit, and it was a little rattled. It got knocked forward, and its camera was no longer pointing at Earth, so we had to get it back to the right orientation, highlighting that while these incidents are rare, they are possible. The effects of meteor showers and outbursts generate great interest not only in space, but also here on Earth. These natural events, seen as shooting stars in the sky, offer observation opportunities for both amateur and professional astronomers. As meteors enter our atmosphere and burn up, they leave short-lived but bright trails, making them a fascinating spectacle to watch. During meteor storms, the number of meteoroids entering Earth's atmosphere can increase significantly. However, most of these meteoroids are very small, burning up before they reach the ground. As a result, the impact on the Earth's surface is usually minimal. Still, when a large meteoroid enters Earth's atmosphere, it can occasionally reach the surface, leaving behind meteor fragments that can be geologically interesting. Observers often prefer a dark, clear sky to enjoy meteor storms. Being in areas far from light pollution allows meteors to be seen more clearly and frequently. Such a natural display can lead viewers to contemplate the vastness of the sky and the enormity of the universe. Observing astronomical events continues to be a source of knowledge and inspiration for scientists and sky enthusiasts. Watching meteor showers and predicting potential hazards in advance is crucial for the safety of space missions. The Meteoroid Environment Office monitors meteor showers through ground-based observations and radar. These observations provide critical data for assessing meteoroid impact risks and taking preventative measures when necessary. Meteor observations come from professional radars like the Canadian Meteor Orbit Radar, managed by researchers at Western Ontario University, and the Southern Argentina Agile Meteor Radar. Amateur astronomers can also contribute by providing observations. The global meteor network consists of over 1,000 cameras worldwide, while organizations like the American Meteor Society, the UK Fireball Alliance, the British Astronomical Association, and the International Meteor Organization accept reports from amateur astronomers. By making valuable observations during meteor showers, amateur astronomers can contribute to scientific studies. We've reached the end of our video about the Perseid Meteor shower and other fascinating meteor events. We hope we've been able to convey the magic of these impressive celestial events. This natural sky spectacle encourages millions of people to gaze at the night sky every year. Meteor showers not only adorn the sky, but also highlight the activity happening deep within the universe. They offer a wonderful opportunity to appreciate how dynamic and awe-inspiring our universe truly is. If you're eager to learn more about these captivating topics and embark on an exciting journey into the depths of the universe, don't forget to subscribe to our channel. Every day brings new developments in science and space, and we're thrilled to share them with you. In each new video, we'll bring you new clues and discoveries about the mysteries of space. Until our next discoveries, keep looking up at the sky. The sky is always full of new stories that will amaze and intrigue us. Until we meet again under the light of the stars and planets, we wish you days full of exploration.